Alright, hello everyone, it's May the 8th. Alright, let's go right into it. So, today's challenge is this, number 17, letter combinations of a phone number. Alright, this is something that's quite old, number 17, so it's a long time ago. To return all possible letter combinations that the number could represent. Return the answer in any order. A mapping of digit to letters, just like that on the telephone button, is given below, okay? So 2, 3 will be A, D, A, E, A, F. Okay. So the digits I is, so I have 4 in the range of 2 to 9 because 1 is going to have 3, right? So we have 4. So the most is 3 times 3 times 3 times 3. That's 81. What we can do is, definitely we do not want to write a nested for loop. So many levels nested for loop. What we can do is basically get out, let's say ABC, DEF, GHI, JKL, right? So we get them out, and we say we want to find A with all the combinations of the remaining, and B with all the combinations remaining, and then C with all the combinations remaining. Right? So this is recursion, right? We can do recursion. All right, let's try recursion. Recursion shall work. Oh, that was yesterday. All right, today we're gonna say for 9th. All right. So digits. So we're given these digits. So I mean, first things first, we want to get a hash map, right? I can call it hash. Ooh, I cannot call it hash. I call it H. So basically, we're gonna say, let's do this. This is these are the 0, 1, 2, the ABC. All right, and then the F, GHI, GHI, JKL, MNO, RS, TUV, and WXYZ. So it's not, let's try 0, 1, 2, 3, 4, 5. No, 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so that's the H. So we're gonna say def helper index, right? We're gonna have an index, and what do we return? We should return a list of str. Okay, so the index tells us this is what we're gonna have, right? This is what we're gonna have. And we say if index is equal to len digits minus 1. So we're having what at the last one. So we're just gonna return list h digits index. That's it. Otherwise, what we have is we're gonna pick the current index, get each one of them, right? And then we'll get the remaining. Right? So we're gonna say R, called remaining, ren, will equal to helper index plus 1. Right? So this gives me a list of all possibilities. And then what we have is pick each one. So we're going to say result is going to be this. All right. And we say for letter in H digits index. All right. So we'll have each one of them, and for each one of them, we're going to have for each one of the others. Say for R in rem, right? And then what we're going to say is letter plus, so we can actually do it this way. We can say letter plus R. And then we'll just return this thing. And then we can just say helper index plus 1. And then we're going to say, we're going to return helper 0. All right, let's try this out. So 2, 3. And given this, shall given us ABC. Okay, so digits, letter, combination digits. All right, we have some issues. List indices must be integers and not str. So we have something wrong with this line. Wait, hold a second, let's see. Helper this should be fine. Right now we return is a list. So each one of this is I see. Wait, hold on. I don't see. I don't see. Let's see these two. Oh, these two are still not right. Ooh, okay. So if not digit, we can do it here. Like if it's equal to if it's larger than, yeah, we can say if index is larger than len. Hold up, index 0 is equal to, right? If it's equal to len digits, we shall return empty. Now okay, this one. All right, the last one. What was the problem? So 0, right? For 0, so we go digits 0 is, oh, we need to go int it. Okay, so I have to, that's why. I see your point. It's okay. It's okay. We just call it int. It doesn't cost too much. It doesn't cost too much. Okay, so that shall be it. Well, this one actually you can write test case like that to try it. Yeah, it's not too bad. So simple recursion shall do. I mean, we could make it, you know what, maybe I should make it this way. 2, right? Yeah, let's make it this way. 3 and 4, 5, 6, 7, 8, 9. Okay. Right, then I don't want to do this. and I don't need to do the int, because now the keys are this. I'm going to say if digits, else this. This is what I want. This is LeetCode 17. Recursion is sufficient. Now, honestly, this might be faster. Sorry. All right, take a look at the past. First time attempt is 2018. 2018, that was a long time ago. 25 test cases. Hey, I see. Backtracking. Huh. That's interesting. I did backtracking and then directly tried to do. Oh, so I see the idea is different. Right now, this one's more creating new strings, right? This is on creating new strings instead of backtracking. Backtracking. So backtracking basically just go all the way down and then we backtrack, right? Yeah. And say for letter in, for every everyone we reach it, we just append one and go to the next one, and now we're backtracking by popping it. You know what? I think we should try backtracking. I haven't written backtracking for a long time, a really long time. Is this original? Interesting. Oh, what is this? Oh, interesting solution. We get a first one, right? And then we get everything from the first one. And then we'll get the next one, put them together, and then we replace. Then we'll get a new one. Oh, wow, these are good solutions. These are really good. Really good solutions. It's like rolling it. Yeah, let's try. I want all these solutions. All good solutions. It's actually including all this. Alright, so let's start with backtracking. So this is backtracking. I haven't done backtracking in a long time, so it's good to try it. Alright, and then we need index as usual, but also need a current, which we call it a list of str, and this is what doesn't return anything. I'm going to say if index is equal to len digits minus 1. Okay, it's equal to, and then what we're going to do is the current, right? And we just say rest.append this dot join current, else, and for this we're going to go through every single one, right? We're going to go through every single one, and then what do you do when you go through every single one? So this is a new thing, which is append to the back of current, and what we say is for letter in digits index, then H, this thing, right? So for each letter we encounter, we say current.append letter, and then we pass it. So helper index +1, and then current, right? And then they will go all the way to down, and then once we finish, or after we append this, we do whatever we do, and after that, current.pop. So this is backtracking. And once we're done, we're done. And then we call helper 0, and current is nothing. Right? Current is nothing. And then we say in the return just say digits, right? We call this interesting, not correct. It should be for every one in current. Right? It should be, because this the letter is something we want to add. So current is the current thing. Hold on, let me think again. So at each one, we add one letter, right? So current, we append a letter, and then go to the next one. The next one, current, shall append a new letter. Why just ABC? Oh, my bad. This is backtracking. Ooh. Okay. So back to 45. What's the last one called? The last one, can call it rolling. Okay. Let's call it rolling combination. I don't think that's a real term, but you know what I mean, right? So we have a start. Now we kick start. How do we kick start? I have digits, and I say digits 0 and H, this thing. Okay, this is start. And then from the second one, we're gonna get everything from the previous, and then we're gonna push the second one. All right, everything, get the second one, and then all of these, each one. So yeah, we have ABC, right? And now we have D, E, F. So ABC come out, everyone hit everything. So we're gonna be ABC, AB. So ABC, we're gonna hit this, ABC hit this, ABC hit this, and put them together. And now we have a new thing, and everything hit. So what we're gonna do is for D in digits. Okay, and then we're going to have a temp, and then we're going to say for r in res, right? For r in res, each one we're going to hit, and then say for letter in HD, so temp.append r plus letter. Once we're done, res equals temp, and then I'm going to return res. Yeah, it's like a rolling. This one's slightly faster, but that's fine. Okay, so we're done with this. All right, let's have some fun. For number 1, intersection of multiple arrays. Given a 2D integer array, nums, where nums I is a non-empty array of distinct positive integers, return the list of integers that are present in each array of numbers, sorted in ascending order. So we want to find the same that's appearing in every single one. So what we can do, right? What we can do is we can set them, right? And then we do intersection. How many do we have? 1,000. Yeah, I think it should be fine. Set intersection, intersection, intersection. So I think that shall do if we do set. I'll just say for row in nums, right? And then what we want everything to intersect with the others. Isn't that reduce? Is reduce? I think it's val element, and it's value dot intersect. Oh, hold on. Actually, I'm not sure. Intersection. Let's say another set. Let's create a new thing. That's fine. So intersection, right? Element, and then we say nums. And when it start with an empty, what do we start with? Set row for row in nums. Turn everything into a set. Okay, how about we return this? Sorted. For empty set. Reduce. Of course, I forgot to do that. Definitely not the fastest because using all these this is a naive solution, but perfectly fine for a contest. What would be a smarter solution for this instead of set? Count. Yep. That is the right thing. Counter. Set the intersection. Oh, you can use a map. Oh, yeah. You can use map. This is better. This is way better, man. Come on. Let's be honest. If you want to play with functional programming, you gotta learn how to use map. Is map gonna be in here, I think, as well. So set dot intersection. Hold on, what is this use? Set dot intersection. What does this one do? Set. See, this is the thing I don't like. Hold on, what is set? Class set. Where is set dot intersection? It didn't tell me the, it just said the data structure. Ah, look at this. Set dot intersection. You can put all of them together. Nice. Nice, I see. So I can just say set. I don't no need to use reduce intersection. I can just say set. Map, I think, is not needed. Intersection does not apply to generator. Oh, you gotta be kidding me. Cannot do generator. Oh, wait, hold on. Oh, shoot. Now I see. Now I see the problem. I have to spread it. I have to spread it. So use set dot intersection. Set 1, set 2, to avoid using reduce. This is from Lee to 15's comment. I mean, I can see that counter works. So for each one, we do a counter, and then we add all the counters together. We find. I can try that as well. That is not bad. Yeah, but this way you have to spread. See, don't use reduce. Use reduce is slower. This one's faster. Wow. So pretty. Do not use reduce. Alright, we have a solution 3. So what is the solution 3? Our solution 3 will be using counter. Actually, I didn't think about this one. So what we want is to find, and then we to add them together, right? So when you say for row in nums, we counter them, right? And now we sum all these counter together, and then we say for key value in sum this dot items if value is equal to len nums, and we put key, right? And then we sort this thing, and I'll return this. Let's see. Syntax error. Unsupported. Int and a counter. How? I don't have int and a counter. Wait, hold on. This one is not allowed. Nope. And how do you do this in one line? I don't know. Oh, I see. It's counting every single one. No, I don't like that. I do not like that. So what I can do is use reduce. I mean, I'm already on this train. Might as well just use using reduce. So reduce. We're gonna get getting nums, okay, and then lambda val element val plus counter element. Only concatenate. Initial value should be counter. How about this? Yeah, this one works. Not the prettiest, but it's fun. Stupid. So slow. Alright, so this one's done. Let's see. Been doing this for 37 minutes, and we can hang on a little longer. Let's see this one. Count lattice points inside a circle. Given a 2D integer array, circles, where circles I represent the center and the radius of the ith circle drawn on grid. Return the number of lattice points that are present inside at least one circle. The number of lattice points that are present. Lattice point is a point with integer coordinates. Points that lie on the circumference are also considered to be inside of it. So if I give you a circle, wait, hold on. Okay, I have a center, 2, 2, radius is 1. And I want to ask the lattice points with the inside circles are 1, 2, 2, 3, 1, 2, 2, 1, 2, 2, 2, 3, 3, 2. Okay. Gotcha. So at least one circle. So the circles can overlap. I have 16 points. I see. I see. So basically, for each, right, for each, we can try to find out everything and put them into a set, right? So that one is done. So for each, we have a reach. So we just search through every single one. Search through every single one. We can calculate the distance. I calculate the Euclidean distance. And these are all integers. But if you think about it, no matter what, right, this thing, which was large, it will go up. If we can find, like, we know if we can find the biggest square, right? The biggest square. So if you think about it, we have a square, right? If I have a circle, the biggest square, then everything inside the square, they are all inside. And then how do we find that? You took your time out if you go a stupid way. So, I mean, for one thing, it's symmetrical. So we only need to do one side, and all the other sides are done. So what we do is we go from here, we go all the way out, right? And then we go up. and we go in. Find the first one that's inside. But that might not be. You know what? I might just go with the stupidest way for this. Hold on. When we go same time. Enticement number one.
And last night you finished it all?
We finished 90%. The rest he just can't. Just to help him through this difficult time. whole 11 cans left. Why can't these food made like this? And you see, not really eating food, you're just baking. I'm afraid I get addicted to this. Alright, back at this. We don't need to count half of it. So like none of the food we have. It's pretty sad. We don't need to count the. Alright, I have no intention to keep doing this. I'm gonna end this. Alright, adios.